Hello friends, welcome back to my YouTube channel Chembasis. So in this lecture I am going to discuss about a very important topic that is called Index of Hydrogen Deficiency. So this Index of Hydrogen Deficiency is very important parameter to determine the structural information of any organic molecules. So how this index of hydrogen deficiency can be calculated from the structure of any molecule, and what are the information that we could get from this parameter, all those aspects will be discussed in this lecture. So friends, let's start the video. Now the definition of index of hydrogen deficiency is the difference in the number of pairs of hydrogen atoms between the compound under study and an acyclic alkane having the same number of carbon atoms. Okay, so basically we know that the general formula of any acyclic alkane is CnH2n. So as an example, you know that the formula of ethane is C2H6, the formula of propane is C3H8. So you can see that the general formula of any acyclic saturated alkane is CnH2n plus 2. Okay, now let's understood how this index of hydrogen deficiency can be calculated. Now suppose we have two compounds. The first one is 1-hexene, which is having a formula C6H12, and another is cyclohexane, which is having a formula of C6H12 also. Now you have to calculate the index of hydrogen deficiency of these two compounds. So how can you calculate? So first of all, you have to identify what is its corresponding acyclic alkane. So the corresponding acyclic alkane is hexane. So hexane also contains 6 carbon atom and it has the formula of C6H14. Okay. Now if you see the formula of the acyclic alkane and these two compound, you can see that there are basically deficiency of one pair of hydrogen between these two compound and this compound. So friends, this difference in the number of pairs of hydrogen is basically nothing but the IHD or index of hydrogen deficiency. Okay, so let's see some more example to understood it more betterly. Now these are the compounds 1,3-butadiene, but 1,3-ine, 1,3,5-hexatriene. So these are the compounds and you have to determine the IHD of these compounds. So first of all, to determine the IHD, you have to determine the molecular formula of these compounds. So you can see that 1,3-butadiene has a molecular formula C4H6. This compound has a molecular formula of C4H4, and this compound has a molecular formula of C6H8. Okay, now you have to determine the its corresponding acyclic alkane. So you can see its corresponding acyclic alkane is C4H10. Similarly, its corresponding acyclic alkane is also C4H10, and its acyclic alkane is C6H14. So basically we know that the formula of corresponding acyclic alkane is CnH2n plus 2. So using this formula we have calculated the formula of its corresponding acyclic alkane. So you can see that as it has total 4 carbon, so its corresponding acyclic alkane has the formula of C4H4 into 2 plus 2, that is C4H10. Similarly, we have calculated the formula of acyclic alkane of all these compounds. Now the IHD will be calculated simply by using this following equation. That is first of all, you have to put the number of the hydrogen atom of corresponding acyclic alkane, that is 10, minus the number of hydrogen atom of that corresponding compound, for which you have to calculate the IHD, that is 6. So 10 minus 6 divided by 2, so it will be 2. So that is the IHD of this compound. Similarly, here also same thing. Now the number of hydrogen atom for this compound is 10, and the number of hydrogen atom for corresponding this compound is 4. So 10 minus 4 divided by 2, 3. And for this compound you can see that the formula of its corresponding acyclic alkane is C6H14. So 14 minus 8 divided by 2, so 3. So the IHD of this compound is 3. Now these are basically mathematical way how we can calculate the IHD, but there is something very simple way to calculate the IHD, and using this simple way you can simply skip this mathematical process. So first of all, if there is any double bond in your organic compound, then that double bond will contribute one IHD. So if there is one double bond, means the IHD of that compound is 1. Similarly, if there is any triple bond in the compound, it will increase the IHD of the compound by +2. And if there is any ring in the compound, then it will increase the IHD of that compound by +1. So let's see how we can use this simple way to calculate the IHD. Now, first of all, there is a very important thing that I am going to share is that there is a type of reaction that is called hydrogenation reaction. So in hydrogenation reaction, what you will do, that whenever any alkene react with hydrogen, so it will be converted into its corresponding saturated alkane. However, if there is any ring, so you can see if there is any ring, then it will not participate in hydrogenation reaction. So this hydrogenation basically allow to distinguish between any double bond or triple bond or ring. So suppose you take an example of this two things. The first compound is 1-hexene and the second compound is cyclohexane. Now both this compound has IHD of 1 because it has one double bond, so that's why it has IHD of 1, and it has one ring, so it also has IHD of 1. And so how you could actually distinguish between these two compounds? So to distinguish between these two compounds, you have to took the help of hydrogenation reaction. So this compound will participate in hydrogenation reaction and it will be converted into hexane. However, in this compound, as it do not contain any double bond, it will not participate in hydrogenation reaction. So there will be no reaction. So by using this hydrogenation reaction, we can actually distinguish between any double bond or triple bond or ring. So how we could distinguish between double and triple bond? So let's see that this is a compound that is cyclohexene, which it has one double bond, and on the other hand it is 1,3-hexadiene, so it has two double bond. So how we could distinguish between these two compound? Simply by hydrogenation reaction, because this compound will consume only 1 mole of hydrogen as it contain only one double bond. On the other hand, this compound will consume total 2 mole of hydrogen atom as it contain 2 double bond. So you can see that both these two compounds are having same formula, same molecular weight, but still we can distinguish between these two compounds simply by using this hydrogenation reaction. Okay. Now let's solve one problem. So here in my lecture, I am always trying to solve 2 or 3 problems so that you could actually whatever I have told you, whatever the theory I have told you, you could actually apply those theory to actually solve some problems. Okay. So first of all, the question is, what is the index of hydrogen deficiency of 2-hexene? So you can see that this is the formula for 2-hexene. So if you haven't gone through the nomenclature of organic compound, I will give you a link in this portion where I have talked about how to do the nomenclature of different types of compounds. So you can see that the name of this compound is 2-hexene, and from there you have to draw the structure of this compound. Now you can see that there is one double bond. So as there is one double bond, this compound will have IHD of 1. Okay, so this is the index of hydrogen deficiency of 2-hexene. Now another compound, that is methyl cyclopentane. So we have to calculate the IHD of this compound also. So you can see that this is the formula of methyl cyclopentane, and it has one ring, so it also will have an IHD of 1. Okay, so the next question is, does the index of hydrogen deficiency reveal anything about the location of the double bond in the chain? So its answer will be no, because if it is 2 hexane or 2 hexene or 1 hexene or 3 hexene, whatever it is, the IHD will be 1 only. So there will be no way how to actually differentiate between these compounds for using this IHD parameter. So that's why this IHD parameter cannot able to tell you the position of the double bond. Similarly, this IHD parameter will also not able to tell you the size of the ring, if there is any ring. So that is the question, that about the size of the ring. So whether it is cyclopentane or cyclohexane or even cycloheptane, all these compounds will have IHD of 1 only. So using this IHD, that is index of hydrogen deficiency, we cannot tell about anything about the location of double bond or the size of the ring. Okay, now the next question is, what is the index of hydrogen deficiency in 2-hexane? So this is the formula for 2-hexane. So as this compound contain one triple bond, so that's why it will have an IHD of 2. Now the next question is, in general terms, what structural possibilities exist for a compound with molecular formula of C10H16? So you can see that for C10H16, we have to determine what is its corresponding acyclic alkane. So the formula of its corresponding acyclic alkane is C10H22. So the IHD will be simply 22 minus 16 divided by 2, so 3. So there are basically 5 types of possibilities in these compounds. So as it has an IHD of 3, so it could have 3 double bonds. So each double bond will contribute 1 IHD, so total 3. So maybe it has 1 triple bond and 1 double bond. So 1 triple bond will contribute 2 and 1 double bond will contribute 1 in IHD. Another way is 1 ring and 2 double bonds. So 1 ring will contribute 1 and 2 double bond will total contribute 2. And fourth way is that 1 ring and 1 triple bond. So 1 ring will contribute 1 and 1 triple bond will contribute 2. And another way is it could have 3 rings. So each ring will contribute 3, so total 3. So these are the all 5 possibilities that it could have. Okay. Now there is another question that is called zingiberine. Maybe I pronounce it wrong. So this zingiberine is a fragment compound isolated from ginger. So it has a molecular formula of C15H24 and it is known not to contain any triple bond. So this compound do not have any triple bond. So the question is, what is the index of hydrogen deficiency of this compound? And when this compound is subjected to catalytic hydrogenation reaction using an excess hydrogen, 1 mole of this compound absorbs 3 moles of hydrogen and produces a compound of formula C15H13. So how many double bond does a molecule this molecule has and how many rings? So let's see this. So first of all, it is told that the molecular formula for this compound is C15H24. Now the molecular formula of its corresponding acyclic alkane is C15H32. So the index of hydrogen deficiency will be 32 minus 24 divided by 2, so 4. Now it is told that this compound is participated in a hydrogenation reaction and it consumed total 3 moles of hydrogen atom. So and it is converted into C15H30. So you can see that although it has index of hydrogen deficiency 4, but it consumes not 4 moles of hydrogen, instead it consumes only 3 moles of hydrogen. So it means that there is 1 ring. So that's why this ring do not participate in the reaction, and that's why we can understood from this hydrogenation reaction that this compound should have 1 ring. Now as this compound actually absorbed 3 moles of hydrogen, so there are basically two possibilities. It could have total 3 double bonds, so each double bond will contribute 1, and it could have 1 double bond and 1 triple bond. So now it is already told that this compound do not contain any triple bond, so that's why we could say that this is the possibility that it has total 3 double bond and 1 ring. So now let's see the structure of this zingivarin compound. So you can see this is the structure where it contain 1, 2, 3 triple double bond and 1 ring. Okay, so this is the way you could solve this problem. Now there are some other problem how you could actually determine the index of hydrogen deficiency for compound that contain halogen or oxygen or nitrogen. So there are some rules that you have to follow while calculating the IHD for these types of compound. So for halogen, you have to simply count this halogen as hydrogen atoms. So let's say take an example. So suppose you have to calculate the IHD for this compound C4H6Cl2. So simply you have to count this 2 chlorine atom as 2 hydrogen atom. So simply you have to replace this 2 chlorine atom as 2 hydrogen atom, and you have to calculate the IHD for C4H8. So the IHD for C4H8 is simply 10 minus 8 divided by 2, that is 1. Okay, so you can see that either this compound contain 1 ring or 1 double bond. From this IHD we can say now whether it contain 1 ring or 1 double bond, that can be determined from hydrogenation experiment. If this compound consume 1 mole of hydrogen, then it contain 1 double bond, and if this compound do not participate in any reaction, then this compound contain 1 ring. So hydrogenation reaction is very crucial to differentiate between double bond, triple bond or ring. Now what happened for compound that contain oxygen? So in that case we have to simply ignore the oxygen, and then we have to calculate the IHD for the rest of the compound. Let's see this. So you have to determine the IHD for this compound C4H8O. So you have to simply ignore this oxygen, just ignore this and calculate the IHD for C4H8, this compound. Okay, so you can see that the calculated C4H8, the IHD will be 10 minus 8 by 2. So 10 means C4H10, that is its corresponding acyclic alkane. So this 10 minus 8 divided by 2, 1. So it has IHD of 1. So now you can see that there are various possibilities of structural possibilities for this compound, as you can see, as this compound also could contain C double bond O. So this C double bond O could also contribute IHD 1 for this compound. So that's why this compound has various of possibilities. Suppose it may be an alcohol with double bond. So this double bond will contribute 1. So, and the position of the double bond could also vary, because IHD do not say anything about the position of the double bond. Similarly, it could have C double bond O. So this will also contribute 1 to the IHD. Okay, it could be ketone, or it could be aldehyde, or it could be like this compound. Okay. Now for compounds containing nitrogen atom, what is the way to determine the IHD? Then in that case we have to subtract 1 hydrogen from each of the nitrogen atom, and then we have to ignore the nitrogen atom. So let's see that how you could calculate the IHD for this compound. So as this compound contain only 1 nitrogen atom, so for 1 nitrogen atom we have to subtract 1 hydrogen atom. So if you subtract 1 hydrogen atom, then the formula for that compound is C4H8N, and you have to simply calculate the IHD for C4H8. Okay, and the IHD for C4H8 is 10 minus 8 divided by 2, that is 1. Okay, so these are the various possibilities that the structure of this compound may have. As this as C double bond N is also possible, so it will increase the number of possibilities of different structure in this compound. So that's it from the this index of hydrogen deficiency lecture, and I hope that you understood all the aspects. And if you do have any queries, please let me know through the comment section, and thank you for your kind attention.